Yeah, so I'm here to talk about a problem that no one really talks about until it becomes a problem for your application. My name's Gordon. I'm a staff engineer at Buildkite. I work on the validate teams, and I've been working in lots of different industries in the past decade, some local companies, fintech and energy sector, and Buildkite has been my gig for about 4 years now. Buildkite is a company that helps world-leading engineering teams deliver software at incredible speed. We're best known for CI/CD, pipeline orchestration, and so we help companies like Slack and Reddit, Canva, and others to ship their products. Database IDs have been quite controversial, maybe pre-2024. This is a quote from one of our principal engineers, Paul. Internally at Buildkite, I'm going to spoil a few things, but yeah, we had a lot of discussions internally about should we use integers, should we use UUIDs, and so this talk is quite interesting for me. We had a lot of incidents in the past to deal with our databases, some war stories I'd like to share, and hopefully it's going to be really interesting. So I'm going to be talking about database identifiers, and I'm going to do a comparison between UUIDs and integer IDs, and might go deep dive into UUID v4 and talk about why that might ruin your database performance. And I'm going to try and pitch to you that maybe you should use UUID v7 as your primary key rather than integer IDs. And along the way, I'm going to be sharing a few battle stories, war stories along the way. I'm going to be sharing a lot of stories. I delved into the history of Buildkite. We have a lot of internal posts and blogs and Slack messages, and I felt like a historian researching this topic. I'm collecting a lot of stories from the team, and full credit to the team who had to deal with being paged in the evening or in the weekends to deal with some of these issues that have come up for Buildkite. So let's go and look at what a Rails application looks like. So this is a database migration. Everyone should be quite familiar with this. Every app starts with maybe a users table, and the default identifier is an integer step. I mean, since this is, I guess it's an integer, but you might get a 32-bit int or a 64-bit depending on the age and version of your Rails application. So for Buildkite, in 2013, the first commit was made, and that was Rails 4.0. I think it was an RC version, if I recall correctly, RC1 maybe. And what we got was 30-bit signed integers. It wasn't until, I think, 2017, Rails 5.1, that big integers, the signed 64-bit integers became the new baseline. Integers, 32-bit ints, that provides about 2.1 billion numbers. It feels like it's enough, and for Buildkite it was for about 10 years. For about 10 years it was quite successful, and the app was humming and working as expected until one day things didn't work. Things started cracking around 2019. So let's talk about database identifiers. So every database probably in the world defaults to using integers. You might get a regular integer, which is 32 bits, or 8 bytes? No. 8 bytes? Yeah, 8 bytes. 32 divided by 8. And that gives you about 2.1 billion values. You might be wondering, where's the other 2.1 billion? So that's 2.1 positive numbers. You have 2.1 negative numbers as well that you probably will never use. And as I mentioned earlier, if you're using a more recent version of Rails, you have 64-bit integers, which is 9.2 quintillion. That's probably more than enough numbers for your entire lifetime. So yeah, integers are pretty good. Like, they make sense. We humans can read them and understand them. We can order. They're naturally audible. So the next subsequent number is always larger than the previous one, and they are really great for databases, particularly the B-tree index, which I'll go into a bit more detail later. But there's some downside with IDs, integer IDs. I keep saying IDs. I mean, every time I say IDs, I just think about, I refer to them, you just think about integers when I say IDs versus UUIDs. So yeah, there's some downsides. So one of the downsides is that you might leak information. So think about like user IDs, or like maybe you're a shop and you have order IDs or things like that. People can use that information to infer maybe the growth of your customer base or the number of items you sold. They're also enumerable, which means that someone can just increment the number and see if it works, especially if you have like if you have an access control bug, you haven't correctly authorized a user, someone might be able to access resources they can't, they shouldn't be able to access to. So it's quite common in the past where like, you probably hear about it sometimes, like maybe in social media websites or PayPal or Meta, where like you can, increment the number and then get access to maybe a photo or someone's profile or something like that you shouldn't be able to. So that's what we call indirect, insecure direct object reference attack, IDOR. Another weakness with these integers is that you can't decentralize the generation of these IDs. You have to have a central database or one database that's responsible for generating these IDs. So when you have to maybe shard your databases, which we'll talk about a bit more later, that becomes a bit of a problem. And yeah, as I mentioned earlier, 32 bits isn't enough for maybe some of your larger applications. You'll probably run out. So let's look at the alternative, which is UUIDs. So UUIDs are 128 bits. They kind of look like that. Those hyphens in there are kind of just arbitrary for modern day UUIDs. They used to have a meaning in version 1, but they don't mean much. Under the hood, it's just a big giant number, and we decided to use hexadecimal base 16 to represent it. So to make it a bit shorter, we could shorten it a bit more with like, we can represent it with base 58 or 62, for example. But hexadecimal representation is the convention. Yeah, so in the 1980s there was version 1, but the most common version that people might use is version 4 in the past, which is just 122 bits of pure randomness. There's 6 bits for like version and variant. It wasn't until like 2005 there was actually like a RSC standard published that standardized all the versions of UUIDs up to version 5. So yeah, I want to talk about version 7 next. Oh no, some slides about version 4. Yeah, so why are they so good? One thing is that they're globally unique and there's no coordination. So earlier I mentioned about sharding, and you have to have a central system that issues these IDs. Well, the good thing about UUID v4 is that they you don't have to centralize it. You can have each individual database sort of issue these IDs, and the risk of collision is very small. I think if you generated, 100 million, maybe I got my math. If you generate 1 million UUIDs a second for like a whole entire year, the risk of collision is something like 1 in 11 billion. So effectively, like it's the chances of it happening are very low. Yeah, some of the weaknesses of integer IDs are basically strengths of the UUID. No data leakage, so no more enumeration attacks. But there are some downsides. They're very long and they're not human readable. And they're not, because they're completely random, they're not auditable. And that has an impact on the database, which we'll talk more about later. Yeah, so prior to version 7, I'm probably spoiling things a bit, but prior to version 7, everyone recognized that there was a problem with UUID v4. It was really hurting databases. So Twitter had its Snowflake ID convention, Instagram had their own, and there was an open source UUID system, which was UUID compatible and was actually quite nice. And all these were time sortable, so it solved one problem. But it brought another problem, which was that it was not standardized. So it wasn't built into languages, standard libraries, or databases. There was no like generate a UUID function in Postgres, for example. So it took until 2024 for the industry body to sort of catch up. So UUID v7 sort of solves all the problems that UUID v4 has. It solves it by introducing a prefix timestamp. So rather than having 122 bits of randomness, you have 48 bits at the front. And what that meant is that every new UUID v7 that you generated was greater than the previous ones that were generated. So it was audible, and it still had the properties of being globally unique. And it had none of the performance downsides from a UUID v4. And as of last year, September, Postgres has introduced, has a function built in, so you no longer have to write your own Postgres function or generate your UUIDs elsewhere. So for a long time, you had to choose between integers or UUID v4, but now with UUID v7, it gives you the best of both worlds. So let's talk about why UUID v4 can destroy the write performance. So let's talk about maybe some internals about B trees and indexes. So Postgres, in Postgres and other databases, primary key indexes are stored as B trees. It's a data structure that allows you to, retrieve or find records quickly. And the way it works in Postgres is that you have these leaf pages that are sorted by key, and I think there are 8 kilobytes. Yes, it says on the slides 8 kilobytes. So when you insert a row into the database, you will have to walk the tree to find where to insert that key. And for UUID v4, it's not that fun. So for sequential integers, all the inserts go on the rightmost page, which is really, really good. That page remains in your cache. And if you're reading from the database, that page is cached already. And most users are probably going to be, depending on your application, for Buildkite, users or agents these days are often accessing the most recent records. So it's great to have all of the hot or more recent records all being available in cache. With UUID v4, it becomes a really big problem because the inserts are all random. You can't sort them, so they just insert randomly in a random page, and it just causes a lot of problems for the database. Yep, so we talked about the buffer cache. And I don't want to go into too much detail, but at Buildkite, we had a problem with write-ahead log amplification. So we had a theory about about UUID v4s causing a lot of problems for our war logs, and so we had a little experiment. So UUID v7 wasn't a formalized standard at the time, but we had a preview of the draft, and we thought maybe we could implement UUID v7, but set the version as version 4. So that's what we did. So we presented to our users that this is a UUID v4, but in fact, like the first 44 bits or 48 bits is a timestamp, and that solved a lot of our problems in our database, and we reduced our OR amplification by about 50%, which was pretty good. And yeah, what else can I say about this? No, it's fine. Let's go. Let's keep moving on. Yep. So we cover this. Yeah, UUID. Yeah. So I guess my pitch is use UUID v7 for primary keys on write-heavy tables. It probably provides you the best of both worlds of integer ID and the characteristics of being globally unique and having no central coordination required to generate these identifiers. So we talked about these trade-offs, and so next let's talk about like integer IDs being a ticking time bomb. So before Rails 5.1, 2017, tables used 32-bit signed integers, and so that gives you about 2.1 million records, and that might seem like a lot of records, but like if you're a system that inserts records at maybe 50 inserts a second, that doesn't give you much runway. So if you inserted 100 records every second, you would only have about 8 months of runway before you run out of 32-bit numbers. And we learned that the hard way at Buildkite, not once, but actually twice. In July 2019, one of our engineers noticed that we had about 4% of IDs left on our artifacts database, and it was going down quite rapidly. So we made a decision to switch that column to UUID v4 at the time. And then later in September 2020, our jobs table had about 22 days left, and we decided to switch to big int for that column instead. So you might be wondering why we decided to switch one to UUID v4 and one to big int. And one of the main reasons is just primary foreign keys. So the jobs table there's a lot of tables that reference job ID in our database, and it would have been, I guess, a lot more work, I guess, to switch all the foreign keys as well as the integer. So we made a call there. So for about 10 years, at Buildkite, all our tables had a dual ID system. So we had a big int, which was the primary key, and we used it in foreign keys, as I mentioned earlier, but we also had a separate UUID column, and that was used externally. So in our GraphQL API, our REST API, in our web app, we would often use display the UUID column to our customers. Our founder, Keith Pitt, did not want to use integer IDs for displaying to customers. So we had sort of like a hybrid situation where we wanted, IDs were good because we knew that for internal use, they're good for lookups, but also external UUIDs are more familiar, I guess, and more friendly, I guess, for a customer. The trouble was that this was fine for about 10 years until our database had some really big problems. David Barrow, he gave a talk, I think maybe last year, about how Buildkite had one of the largest RDS instances in Australia, and we were hitting lots of load problems, and our SLOs and SLAs, our service level objectives and agreements we were testing those thresholds at some points, and sometimes we would breach them as well, and our customers weren't happy with some of the incidents that we had at that time. There was a lot of people being paged, a lot of incidents, it was quite evident that we couldn't just keep going with a single database, so we had to break up the database and shard it. So we had to break it up and put customers in different databases. Or sharding was a problem. We can't rely on the Postgres sequences to generate integers. So we had to make a decision at the time to I guess, draw a line on the sand and say, like, any new tables now we need to use UUID v7. One of the engineers says that if we don't do this now, it will just be a big problem for our future sales. So that was one of the calls that we had to make as part of this sharding project. We've gone all in basically on UUID v7 today. So yeah, foreign key trap. So that's something that has come up for Buildkite as well. So you may have upgraded your primary key to 64 bits and given you basically infinite time, let's say. But your foreign keys, you may have forgotten about some of your foreign keys. So even though you have enough space for your primary key, your foreign keys might blow up and cause an outage. Another thing that did cause us some problems was that GitHub had IDs that also overflowed the 32-bit space. But internally, our systems was using a 32-bit column, and we learnt the hard way about that too. Oh yeah, let's talk about that Civ1, which was a really fun story, maybe for some people, not for the people that worked on it on a Saturday. So yeah, our agent's ID table was 64 bits, so that was fine. It was a big int. But our foreign key, one of our foreign key tables, jobs table with referencing agent ID, was still 32 bits. And so this was really funny. It was an incident. There was an outage, basically. Our customers were impacted. We had to race to make a decision to put something in place very quickly. So we implemented a hack, and we were still a single database at the time. So we were able to still rely on sequences. And so we basically told Postgres to start counting backwards from -1 down. And that meant that we didn't have to write a schema migration or database migration to update that foreign key for at least a bit of time. So it bought us a bit of time. I think we calculated that that would give us about 2.8 years of space for a growth rate at a time, which is basically now. But one thing that we were hoping is that we would shard our databases and this would just be no longer an issue. And I wouldn't want to spoil that sharding talk. You should go watch it. But yeah, it was a pretty fun thing to read about. So internally at Buildkite, we write a lot of posts and share a lot about this stuff, and we write a lot of post-mortems. So it's quite fun, and for me at least, to see, oh, we solved this by counting backwards. So let's talk about, this thing happened again in August 2024, but this time we had time. We noticed it before the system was broken. So we discussed it internally, and we said, we don't want to use any negative IDs here. We decided for a UUID v7 migration for this table. So yeah, just a key takeaway here is that negative IDs are a great hack to buy you runway in an emergency, but not really a long-term solution. I'm going to speed run sharding. So I kind of hinted about this earlier. Using in a sharded database environment, you can't really use integers IDs, or you can, but they're not ideal. You really want to use UUIDs basically to allow each database to generate their own identifiers without any risk of collision. There's a few solutions. I talked about UUIDs. One solution, which we actually utilized, is interleaving these sequences. So imagine if you had 4 shards, so 4 different databases. We would have each database increment by 4, starting from a certain number. So each database won't overlap, basically. So that's what we did, actually, rather than switching over to UUID. So we did some math, and we said, okay, this will work to allow us to shard our databases, but we increase our burn rate. Not all of the databases will issue or use ID sequences at the same rate, so we did some trade-offs with this approach. One thing that we also considered was doing a custom style shard ID, similar to like what Twitter did with their Snowflake IDs, but that was pretty I think at the time we decided it was really complex, and we just decided to use interleaved sequences. I think it was a pragmatic choice at the time. So let's talk about another incident. So yeah, as I mentioned earlier, we were breaching our SLAs. We had to horizontally shard the pipelines database, which was our big giant database at the time. We decided that all primary keys should use UUID v7, and for existing integer sequences, we did this interleaving strategy. It brought us some runway, but it also meant that you couldn't rely on IDs being the you can't rely on IDs being chronologically ordered anymore. So that was a bit of a downside. I'll skip what I was going to say something, but I will just skip over the detail. Okay, so we decided on UUID v7. So just to summarize the talk really quickly, UUID v4s were pretty good, but it hurt your database. And you should use UUID v7. It has all the benefits of v4, but also is quite good for your database as well. I wrote a blog post about this, and it somehow got popular on Hacker News, and someone mentioned in the comments that, yeah, like it's almost like really good, but there's one downside with v7 is that you kind of, because you're prefixing the timestamp in your UUIDs, it meant that you are kind of leaking information. Like looking at a UUID, you can tell when that record, that resource was created, so that's something to consider. So I just want to caveat that most cases, like you probably don't care about a record, a timestamp being exposed, but it's just something to think about. Internally, because we have a hybrid system and some legacy database tables still using integer IDs, we decided to label or use a column name that indicated the type. So for our primary key columns, we use UUID, and for our foreign keys, we use underscore UUID. So we formalized that as an ADR at Buildkite. Here's just some code. So this is what it looks like at Buildkite. We don't use a ID column, as I mentioned in the previous slide. We have a column called UUID, and we have a function that we've defined in our database called UUID generate v7 that automatically generates those values for us. I should mention that we also, in Buildkite, we also have a few ways of generating UUIDs. So in our application, we have some functions that would generate the UUIDs for us, and I mentioned earlier that we had these like fake UUID v7s that look like UUID versions 4, but they were basically v7s. So there's like an ordered there's like a function called ordered UUID v4 in our systems, and yeah, I think a recent version of Ruby has secure random has UUID v7 built in now. So previously, I think Buildkite was using a gem or a library to generate them in the application, but now that's no longer required. And then if you're using a more recent version of Postgres, which Buildkite isn't using yet, you would have the V7 function built in as well. So yeah, I mentioned earlier, you either have to use a custom PG function or use a PG extension or generate them in your app. So yeah, just some takeaways for me was that this migration, the sharding database emergency at Buildkite, and the sharding migration was a huge journey. Like it took so many engineers at Buildkite for a very, I don't want to say how long it took, but it took a long time for us to deal with this database emergency. But we're now in a pretty good position. We've onboarded some really large customers, and we're doing more work in isolating customer workloads at the moment, and doing more to handle the growth of AI agents. So something that I took away from this was that don't try and do everything at once. Like just leave all your old tables behind and just set a standard internally and say, look, let's just use, for new tables, let's just use UUID v7 and we'll deal with the old tables later. If they work now, just let them work and we'll just keep monitoring it. And if there's an issue, we'll go and address it when it becomes an issue. Don't use UUID v4 is basically my hot take from this. If you're using them today and you're not encountering any problems, maybe that's fine. But if you can swap them out for UUID v7, it doesn't require database migration. You can use the same existing column, so it shouldn't be too difficult to swap from a v4 to a v7 for your new records at least. So just some key takeaways. I see this again and again. Consider using v7 for your new tables. And if you're if you have a really old Rails app, like pre-2017, you might want to just check some of your tables and make sure you are not using 32-bit integer primary keys and foreign keys. And if you are, you might want to calculate your runway or monitor your sequences to see how much runway you have, and maybe set up some alerting or automated alerting to just notify when you maybe hit some certain thresholds like 50%, 75, and 90%, for example. Also make sure you check your foreign keys as well. Buildkite did not, and that became a problem one day. So we covered a lot of ground. I think I talked about UUIDs versus integer IDs, and some of the stories and incidents that Buildkite faced in the past. And one thing that our engineers mentioned in 2019 was that we really wished we had natural audible UUIDs. And it wasn't until 4 years later v7 arrived. And sometimes it just takes time for, I guess, the community or the standards body to catch up to our problems. And sometimes it doesn't. You have to come up with some interesting hacks like counting backwards. It's been good to talk to you and nerd out a little bit about UUIDs and IDs. So thank you.
Any questions for Gordon?
What was the time for questions?
Yeah, sorry, I went too long.
No, not at all. Yeah. I would love to hear what tools were the most useful. You know, when you were benchmarking the different ID types and looking at inserts versus what tools do you like to use for that kind of database benchmarking?
Yeah, to be honest with you, I don't think we did much benchmarking. We referred to the literature that the community wrote. There were some database experts. I think Percona had a blog post about the index locality problem with UUID v4, and and we experimented on production. I'm probably not revealing any secrets, but we actually don't have a staging environment for Buildkite. We carefully deploy to production behind feature flags and that sort of thing. So yeah, in my talk earlier, I talked about how we had a feeling that V7s would solve some of our problems, especially with our wall amplification. And so one of our engineers experimented with that and safely started using UUID v7 for one of our existing columns. One interesting thing that happened was that we didn't fake it. We actually switched over to v7, and then one of our customers, their systems just failed, and they sent us a Slack message saying, "Hey, why did you guys start using this random version that's not published yet, v7?" And then we were real perplexed. Why is your system checking the version of a UUID in the first place? That's kind of odd. So we had to do a hack and produce a v7, but then change the version bit to a 4, so things continued to work for them. So to answer your question, we didn't do much benchmarking. We referred to articles and blogs and from the community that, and we experimented in production safely. Mostly safely, except for that single customer. Yeah,
engineers must be pretty discerning users. I've always thought that working on a DX tool, checking your UUID version. I have more, but I'll let them. Anyone else?
Does clock sync matter for the milliseconds?
Yeah. So it's 46 or 48 bits. I can't recall. So milliseconds, that might become a problem, I guess, if you have. There is a risk that independent systems might be generating sequences that might not be synchronized in a way. For our purposes, milliseconds doesn't matter too much.
And do you still store a created at timestamp, or do you use? Yeah,
that's a good question. I think Rails by default you do. I think we still do it, but interestingly enough, you would normally have an index on create@, right? For your columns. Now we don't. We just sort by the ID column, so that's one bonus. I was going to say something else, but yeah. It's using UUID v7, you can basically use the same index for sorting. So it's been quite good. Yeah.
You mentioned around entropy with v4. You're it's 1 in 10 billion. Per year. You're losing a bit of entropy with v7?
Yes, you are. That's right. So maybe the 1 in 11 billion chance when you generate 1 million rows per second is maybe 1 in 1 billion, maybe. I haven't done the math. I could probably ask Claude or something to run the numbers for me. But yeah, you definitely have less randomness. Previously you had 122, now you have 74, if I remember, 74 bits. But that's still quite a lot. I think that's more than a few quintillion numbers, and so risk of collision is probably near zero. Yeah.
Could I ask one more?
Yep.
So you did end up changing an integer ID to a UUID that did have foreign keys on other tables. Was it? Yeah. So did you do it with no downtime and populate a secondary column of IDs and then re-index and then change the code to points? How did you do it?
Yeah, that's a good question. We can't be offline. Our customers build things 24/7 on our platform. We had to do things what you described. Create a new column, do some backfilling, and carefully switch over or cut over to the new column.
Have you done much consideration of just like the storage space above 128 bits
Yeah,
kind of thing compared to like big int, which is half that size?
Yeah. Big int is 64, UUID is 128 bits, so it's double the size, and that was put into consideration that, we would double it. We were doubling our indexes effectively.
And references as well.
Yeah. 100, it's extra 64 bits. It's extra 8 bytes. Maybe that would be a problem 20 years ago. Like maybe you can make the case that today it probably it's worth the cost. Yeah. That was mentioned in one of our ADRs. Like, we're doubling the size, but we wanted to stick with a standard that was universal and available in all modern databases and languages. I think in my research, I think there was a company that had their own scheme and they decided to use 64, and we were thinking like maybe we could do something similar, but we just settled on UUID v7. It's a sensible choice.
Given that UUIDs are just numbers, could you migrate an old table by just inserting a UUID into a wider number ID column and keeping the ID column?
Oh yeah, well, so can you migrate an existing integer number and map it into a UUID? Yeah. That's an interesting question. I think you could. I mean, you might run into some problems. I can't think of any. Yeah, I mean, like, that's an interesting one. I didn't talk about. So one thing you could do actually is I didn't talk about other UUIDs. So there's like version 3, version 5, and they're based on like hashing. So they use MD5 and SHA-1 hashing. So you can take a name and hash it, and then that turns into a UUID. We use version 8, which I didn't talk about in the talk, which is like a custom format. Like you can do whatever you want with V8, and we take something that's we take like names and things, and we hash it, and then we map it to a UUID, and it's been quite useful for like a distributed system where we needed deterministic IDs. But I think that's a really good. I didn't think much about that, but maybe that's something you could do. You can either just map the ID the integer number directly into a UUID, but also you could maybe hash it and then map it, just so the UUID looks more random. Otherwise, I guess you would have a lot of zeros, and your integer will be your integer being mapped to a UUID your UUID will look quite non-random. That's what I'm trying to say. So maybe adding a bit of.
I think you might have problems with database performance, because I think a lot of the indexing in the database will populate huge amounts of empty if we start doing that.
Yep. I was wondering if there were any third-party systems, either your customers interfacing with your API or like upstream things, where that change caused problems.
I mentioned earlier that was one customer that was reliant on a version, but I guess like some customers might made an assumption. Well, I mean, previously we were using V4s, so that's probably not good for customers that were potentially indexing in their system. So it's actually better for us to use V7 for those customers.
Any kind of upstream tools we had problems with the switch?
No, not that I can remember. I don't think we can't count any issues with upstream tools.
You mentioned that you're not going to migrate, from all the versions or all the types of IDs to UUID 7. At least you have to, right?
Yeah.
And you're just going to set the standard that UUID 7 is the standard.
Yep.
Which is great, but what if standard changes, right? So so the question is, do you see any flaws in V7 that you might, kind of cause you to rethink?
V7 seems very solid. There's no downsides known at the moment. And if something if it becomes a problem, someone will probably publish a new standard and we'll have to migrate to that one. Yeah. So far we've been pretty happy with our journey. Our engineers are pretty happy with the result. Previously, people would have to set up tables with 2 columns, and I mean, it just wasn't fun. So it's quite nice to just standardize with 1 column with UUID v7. Yeah.
There's one.
Yep.
The historical one.
Yep.
So a long time ago, you thought that integer IDs were bad for customers. You should expose them. There's a quote there. Why did you just go for UIDs as a primary key and clear?
So at the time, I think the team recognized that UUID v4s had some downsides. One that Matt mentioned was the space, but also the index locality problem. So there was an impact on databases that we were aware of.
So you were aware of it?
I think the team was aware of it and didn't want to switch. And so internally there was a lot of discussions like, what should we do? And we settled for a dual ID system at the time. It was not until recently, like 2004, 2005, when that v7 standard was published. That was then we settled on making that decision to switch over. Yeah. Any more questions? Buildkite has some interesting challenges, and we are hiring. So check out the URL buildkite.com/careers for more information. Yeah.